But Baalbek, if there was one example, one ancient site on Earth that is evidence of a lost, ancient, advanced civilization.
And here we are at the quarry in Baalbek, and look at this monster.
Who constructed Baalbek's enormous stone platform? Scientists and archaeologists have been searching for this secret for more than 2,000 years.
Local archaeologist is giving us a tour of the site, but he is a firm believer that this is simply a Roman block that they didn't.
Lost records were blamed by historians. Aliens were accused by conspiracy theorists.
This one right here is what's called the Stone of the Pregnant Woman. It is 1,200 tons.
1,200 tons.
The Romans took the credit for it. Now, finally, artificial intelligence has given us an answer. It studied every block. It ran every scenario, and what it found is simple. The Romans didn't build it. Someone else did. Someone we weren't even looking at. The stone that shouldn't exist. There's a stone in Lebanon so big, so absurd, it's hard to believe it's real. And it's not alone. Tucked into the ancient city of Baalbek, these blocks don't just stretch logic, they crush it. They're heavier than any single object we've ever seen moved in the ancient world. Some weigh over 1,500 tons, which means each one of them weighs more than 3 jumbo jets or over 200 fully grown elephants stacked. How they got these blocks from a quarry probably a kilometer away up to here is a mystery. And yet, somehow thousands of years ago, someone cut these things with near-perfect geometry. Someone placed them with such insane precision that you can't even slide a razor blade between the edges. At first glance, Baalbek looks Roman. The towering pillars, the temple layouts, the inscriptions, all of it checks out. The Romans built it, they say. But then you walk past the Temple of Jupiter, past the Bacchus shrine, past all the marble drama, you discover something staged. Underneath all the typical Roman structures is something else. A platform of stone blocks so massive, so old, and so precisely engineered that it doesn't match anything the Romans ever built. One block is called the Stone of the Pregnant Woman, and recent excavations show that there are possibly larger ones underneath it. A local nickname that has nothing to do with how it was made, and everything to do with how absurdly huge it is. Over 68 feet long, 14 feet wide, 14 feet high. That's the size of a luxury tour bus carved from solid limestone. And right next to it is something even crazier. In 2014, archaeologists uncovered a second stone still embedded in the quarry. There is evidence of at least 2, but arguably 3 different architectures that were done at this site. It had never even been moved. This one, untouched for thousands of years, is over 64 feet long, 19 feet wide, 18 feet tall. And it's been estimated to weigh over 1,650 tons. That would take at least 16,000 people just to lift. Assuming each one could carry 200 pounds, which they obviously couldn't. So, how did it ever move? According to every engineering textbook and Roman technology manual we've got, it didn't. It couldn't. The best Roman cranes could handle about 300 tons, and that's being generous. So, how does one explain a block that is 5 times that heavy, lifted 20 feet in the air, and placed flawlessly? Experts turn to artificial intelligence. Researchers fed the dimensions of Baalbek's blocks into an AI system trained to simulate real-world physics and ancient engineering scenarios. They input Roman-era cranes. They tested rope and pulley systems. They simulated hauling teams, earth ramps, timber scaffolds, every reasonable theory that's ever been proposed. 50,000 separate scenarios were modeled. All of them failed. Some collapsed under weight stress. Others broke apart halfway through movement. A few succeeded in lifting, but only under conditions no ancient civilization could have created, like steel reinforcements or modern elevation equipment. The AI flagged one thing immediately. Transportation was more impossible than lifting. Because even if you could lift the stone, which the Romans couldn't, you still had to move it over half a mile from the quarry, across a slope, over unstable terrain and somehow raise it onto a foundation without shattering it, killing hundreds of workers or sinking into the ground under its own weight. And yet, someone did it. Who had this kind of power, this kind of precision, this kind of knowledge at a time when history claims none of it existed? The remains of these huge base stones were used by later civilizations to rebuild Baalbek. The AI wasn't interested in mythology. It didn't care about who wrote the inscriptions or who took credit. It just ran the numbers, and the numbers told a very different story. The technology required to move, lift, and lock these stones into place wasn't just advanced. It was coordinated, industrial, and methodical far beyond what the Romans, Egyptians, or Greeks were ever documented doing. And that's when a new theory started taking shape. One the AI didn't invent, but helped expose. That Baalbek isn't just Roman, it's built on top of something much older. Something from a time when knowledge was passed through generations of master builders. When tools weren't just crude chisels, but part of a systematic method. When math and measurement were part of the craft, not just rough estimations. A time that left behind no names, no scrolls, no visible legacy. Except these stones. The Romans, for all their glory, never tried to move stones this big again. Not at Palmyra, not in Rome, not in the Pantheon. They saw what was already here at Baalbek, recognized the genius behind it, and simply built on top of it. But now, with AI peeling back the layers of possibility, we're seeing that this wasn't just a fluke of manpower or slave labor. It was planned, engineered, executed by minds that understood stress distribution, geometry, leverage, and terrain management without leaving behind a blueprint. The kind of genius that might have existed long before the Romans ever marched into Lebanon. Before their emperors claimed the land, before they carved their gods into stone. Because the blocks were already there, and someone had already mastered the impossible. And that's what AI just exposed. What the AI saw, artificial intelligence, didn't arrive at Baalbek in a spaceship. It didn't scan the ruins with lasers or decode secret alien signals. It did something more useful. It ran the math. The AI system researchers used wasn't some all-knowing oracle. It was a powerful, multi-layered simulation engine. One that could model how objects interact with gravity, friction, terrain, weather, and human limitations. And most importantly, it could do what no human brain could manage without years of work. Run tens of thousands of scenarios at once. The starting point was simple. Feed the machine every known fact about Baalbek's largest stones. Baalbek, as we know from the archaeological evidence, must have existed during the period between 6 to 8,000 years, or even 9,000 years BC. Then add everything we know about Roman technology, then run it, and almost instantly, the machine started ruling things out. Ramp theories, most collapsed. To haul a 1,600-ton block up even a slight incline. The ramp would have had to be over 100 feet high and several hundred feet long, just to reduce the incline enough to avoid catastrophic drag. That means building a structure that involved more stone and effort than the temple itself, only to demolish it afterward. The AI flagged it as wildly inefficient. Roller systems failure rates were even worse. Wooden rollers snapped under pressure. The stone would either dig into the earth or crack from uneven weight distribution. Even when the system worked in theory, the slightest elevation change sent the whole simulation spiraling into collapse. Levers and pulleys, not enough lifting force. The Romans' best crane could raise about 300 tons, meant under perfect conditions. A six-fold increase in weight just wasn't possible with the materials they had. The machine tried human hauling next to lines of workers with ropes dragging the blocks. The result? They didn't get more than a few feet. Most teams collapsed under pressure, died from exhaustion, or failed outright. Even simulations with 10,000 workers failed due to coordination breakdowns and terrain limits. The AI flagged the logistics as impossible. So, what did work? Not much, but a few combinations caught the machine's attention. When it tested modular sledging, something changed. Instead of trying to move a 1,500-ton stone in one motion, the AI tested a technique where the load was distributed across multiple, interlocked SL ledge ES. Each one absorbed part of the weight, adjusted to terrain slope, and used a system of dynamic levers and lubrication layers like animal fat, water-soaked clay, or crushed limestone powder to reduce drag. The runners were shaped based on terrain scans curved for grip and lined with reinforced hardwood. And suddenly, for the first time in 50,000 simulations, the model moved forward. With enough coordination with the right terrain prep, and with a workforce of maybe 500 to 1,000 trained laborers, the stone could theoretically move across a flat or slightly inclined landscape. Every component the AI used was based on materials and tools known to have existed in the Bronze Age. Once it had a plausible transportation route, the AI moved to placement. How do you lift something taller than a house and heavier than a destroyer ship and slide it precisely into a wall with gaps no wider than a hair? Again, traditional theories fell short. The AI flagged one major pattern across all successful simulations. Coordination. None of this would have worked if the builders didn't have a system, not just tools. Now, the question wasn't how the stones were moved. The simulations gave plausible answers. Who was running this operation? Because the moment the AI zoomed out to track the manpower, food distribution, housing, material sourcing, weather cycles, terrain prep, and tool repair schedules, it uncovered something wild. Supply chains, training regimens, construction phasing, even contingency protocols in case a block cracked or slipped. The AI flagged this as the byproduct of generational knowledge. Teams that had done this before refined the method, taught it, repeated it, perfected it. Which brings us back to the foundation at Baalbek. Because if Romans didn't run this operation, we know their cranes weren't enough. Then whoever did this had systems in place that we haven't found in any surviving record. AI didn't uncover a magical solution. It uncovered proof of organization. That behind these stones was not just muscle, but method and system. One good enough to rival modern-day project logistics. And if that's true, then the civilization that pulled this off wasn't just ahead of its time. It's one we may have forgotten entirely. The builders beneath Rome. Everyone credits the Romans for the building. And at first glance, they deserve it. Baalbek's towering columns, its grand temples, and its marble carvings all scream Roman confidence. But the deeper you look, the more things don't align. We don't know why Baalbek was chosen as the specific site. It may well be some kind of special power place. The problem starts at the bottom because the Romans didn't build Baalbek from the ground up. They built on top of it. And the stones at the base, they're a different story entirely. The lower levels of Baalbek, the megalithic foundation blocks, don't match anything the Romans ever attempted anywhere else in their empire. The closest comparison would be Herod's platform in Jerusalem. But even that falls short in scale, precision, and ambition. These stones form a deliberate, measured load-bearing structure, and nothing about them matches the known techniques of any Bronze Age or Iron Age Mediterranean power. Roman engineers used opus caementitium concrete. It was brilliant, fast, and strong. But they didn't stack 1,500-ton stones. They didn't bother. It made no logistical or economic sense. So why would they start here? Instead, they found a platform that had already been built, one that had already survived centuries, and they used it. They designed their temples around it. The Temple of Jupiter fits almost too perfectly atop the megalithic base. The alignment is no accident. It's adaptation. This rewrites the timeline. Because if the Romans reused a pre-existing platform, then whoever built it came long before and with very different tools. AI analysis confirmed this by running pattern comparisons on the joinery. The stone edges on the lower platform exhibit a fit so tight that no mortar was ever used and none was needed. They interlock, resist earthquakes, and haven't shifted in over 2,000 years. Meanwhile, the Roman sections above, they've been patched, reinforced, and in some places have already eroded. That's not just a style shift, it's a skills gap. And it raises a much bigger question. Who came before Rome? Historians have floated a few names. First is the Phoenicians. They parts of Lebanon and were known for their trade networks, their alphabet, and their temple building. But there's no record, not even a myth of Phoenicians cutting blocks this size. Their cities like Tyre and Sidon were dense, not monumental. No massive stone platforms, no mega structures. They built up, not wide. Second is the Canaanites, culturally and chronologically related to the Phoenicians. But again, no construction record comes close. Their focus was more spiritual than architectural. We don't have evidence they moved stones heavier than 10 to 20 tons. Finally, we have the Egyptians. Now, this is interesting. They certainly had the ambition, and the pyramids show they understood mass-scale logistics. But the Egyptians didn't venture this far north often. And when they did, they didn't leave behind multi-Tannan foundations. Plus, their construction techniques were different. Block stacking, mortar, ramps. No precision joinery like Baalbek's base. So we're left with a layer of engineering so refined, so intentional, that it doesn't fit any known local group. AI models picked up on this disconnect. When it ran the style analysis, comparing tool marks, fit lines, and transport logistics, it couldn't match the base layer to anything else in Roman or pre-Roman archaeology. Instead, it flagged it as anomalous construction system, not supernatural, just unknown. The builders of the base, their name is lost. Their language is gone. No scrolls, no seals, no tools, just the stones. But A might have found their signature in the pattern. Across Baalbek's foundation, the same geometric proportions show up again and again, even across different stones. That suggests standardization. Even more interesting, the same proportions show up in other megalithic sites with no clear cultural link to Baalbek. A few ancient walls in the Levant. Now, that doesn't prove a global civilization. That would be a leap. But it does suggest one thing. Somewhere in Defestri, long before the Romans, there was a culture that knew what it was doing. A culture built to last forever. Lost knowledge or lost civilizations. Every generation thinks it is the smartest one that ever lived. Then it stumbles on something that should not exist. Baalbek is one of those things. It is not just the size that unsettles historians. It is the accuracy. These stones have held their alignment through earthquakes. Their joints have not shifted in 2,000 years. Their edges are still sharp enough to reflect sunlight like machined metal. Whoever built this did not just stack stones. They understood them, and that knowledge, whatever it was, disappeared. Researchers fed AI every measurement from Baalbek. Then they told it to compare those details with thousands of Fanchen sites around the world. AI found matches in the way weight was distributed, in how vibration was absorbed, in how stones were joined at complex angles to lock them in place. The same tapered joints used in Baalbek show up in Machu Picchu. The same corner braces appear in sections of the Giza Plateau. The same vibration of spong-based design used in Baalbek is seen in early Andean sites in Peru. The cultures were different, the continents were different, but the techniques were somehow the same. That alone changes everything because it means people thousands of years apart and oceans away figured out the same advanced engineering and then let it disappear. This is not new. History already shows it happens. The Romans made a form of concrete that still survives in seawater. Then the formula was lost for over 1,000 years. Gothic cathedrals used ratios and acoustic principles no one fully understood for centuries. China once made steel so advanced that later dynasties could not recreate it. So why is it so hard to believe that Baalbek's builders knew something we forgot? When AI ran its simulations using only confirmed Roman technology, the platform failed. But when it used theoretical techniques that matched the stonework patterns, things like load distribution layers, pivot joints, dynamic ramps, everything started working. These methods could not have been used once and forgotten. They took time to learn, time to test, time to teach, and then somehow they were gone. So maybe Baalbek is not just a temple platform. Maybe it is a message. A message left in stone saying this was possible once and then it was lost. None of these cultures left behind machines, but they left behind the results. That is what AI is piecing together. Now at Baalbek, it found something else, something subtle. The measurements, the stone sizes, the spacing. They follow a pattern, not random, not aesthetic. It suggests a shared unit of measurement. The angles between stones are mathematically consistent. The proportions repeat. The base of Baalbek was not a guess. It was calculated. So who did the calculations? There are no records, which means the builders either wanted their work to speak for itself, or they assumed their knowledge would never be forgotten. But was it just knowledge that disappeared, or the entire civilization that created it? The truth is, we do not know, but AI is helping us ask better questions. It is running patterns faster than any human team ever could. It is identifying tool marks, alignment strategies, friction modeling, and load angles that show this was not guesswork. The stones at Baalbek were moved, lifted, and placed by people who knew physics, not just superstition. They understood seismic resistance. They understood force angles. They understood materials. And then at some point, they vanished. If they were wiped out by disaster, their genius went with them. If they were absorbed by another empire, their methods were ignored or replaced. Either way, what they knew has been missing for thousands of years. The AI models call it unrecorded knowledge. But maybe that is the polite version. Because what we are seeing at Baalbek is not just an engineering marvel, it is a ghost of something greater. A civilization that reached for permanence and almost made it. All that remains is stone. And now machine learning is reading that stone like a forgotten book. Why it matters now. Once artificial intelligence got involved, it stripped away the guesswork. It modeled every tool, every terrain, every possible method. And in doing so, it confirmed what many had quietly suspected for years. The Romans were not the original builders. The foundation of Baalbek came from somewhere else. Its creators were working from a system, not guesswork. A system built on long-term planning, precise measurements, and high-level logistics. They were engineers in every sense of the word. And they left behind something even the Roman Empire could not replicate. The Romans built many wonders, but not this. Their temples sit on top of a foundation. They did not create their own stonework, has cracked and weathered. The platform beneath it has not moved for centuries. That difference was ignored. Some dismissed it. Others explained it away. Most never questioned it at all, blamed it away. Most never questioned it at all.